Next, we are going to determine the molar mass. We follow up this one. In the highlight point, after we get the number of mole of sample used, actually we can use the mass over molar mass equals to number of mole to find the molar mass. Here shows mole ratio. We can find the number of mole, and don't forget we can calculate or measure the amount of substance we input, that is the mass, and of course the molar mass can be found. So let's have an example, and here we highlight the information. You are feel free to write down the equation first, and again write down the information, and we calculate first the amount of HCl used, m times v, we got it. And from the mole ratio we can find the amount of carbonate, M2 carbonate used. Don't forget mention in titration. And next is a bit complicated. We find the number of mole of carbonate, M2 carbonate used, and after calculation it should equals to the number of mole. Don't forget we have diluted our solution. So with further calculation, we get this one. It's a bit complicated. You need to solve the equation. This is the formula. Mass of M2CO3 is 138.33 just without unit, and the relative atomic mass of M equals to, first we minus the mass of carbon, then we minus the mass of free oxygen and divided by 2, because this is M2CO3. It's about 39.1 something. So we can sure M is K. This can be found from periodic table given. Don't worry, you no need to memorize any number. Now let's move to our checkpoint. In these questions, we are going to find the relative atomic mass of M. We try to highlight the information first. Here we have the mass of the metal hydroxide and diluted to 250. Extract 25 cm cube to carry out titration against hydrochloric acid, and this is the volume of Ti. So here is the illustration, and you can see it is better for us to find the number of mole of HCl first. But before everything, try to write down the equations like this. And number of mole of HCl equals to this amount. Next, from the mole ratio between the metal hydroxide and hydrochloric acid is 1 to 2. So we can find out the number of mole of metal hydroxide used, and here shows. But don't forget, we are going to find the relative atomic mass. So here shows 2.6 gram over the molar mass of the metal hydroxide. Well, this is not the exact mass we're going to use. Don't forget we have diluted the solution, and after solve the equation we got this. Furthermore, and here shows, this is how we find the relative atomic mass from the number of mole used in titration.